Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, as we have discussed in the previous class, we have discussed about we have been discussing about the various measurement techniques or the instruments that we generally use for measurement, and regarding that we have discussed about the concept of the vernier scale, isn't it? So today we will be specifically going to discuss about the vernier calipers, an instrument or a device which is actually based on the principle of vernier scale. Okay, so without wasting much time, let us quickly move on to our topic of discussion, that is vernier calipers. Okay, before beginning the video, I have a small request. Please do subscribe the channel, like the video so that these videos can reach to many other students who require this kind of videos for their learning purposes. Okay, and if you have any query, please do mention in the comment box. We will be happy to solve your problems. Okay, so let's begin. Okay, so today our topic will be vernier calipers. Okay, so make the heading vernier calipers. Okay, now okay, so what is vernier calipers? Basically it is this vernier calipers it's an instrument which is used for measuring very small lengths. Okay, generally we have measuring tape, measuring scale. These are used for measuring large distance, actually large lengths, not very large but still large, in the order of the centimeter or millimeter. Now if you want to measure lengths smaller than millimeter, okay, then we need to use this kind of vernier calipers. Okay, also these vernier calipers, you can also see in many books, it is also known by the name of slide calipers. So it is also known by the name of slide calipers. Why these slide calipers? Because actually when you see the construction of the vernier calipers, there are two scales. Okay, one is the main scale and another one is the sliding scale, or which is called the vernier scale. So that's why the name vernier calipers is also known as slide calipers. Okay, now so if you were wondering that what kind of measurement do we make with these vernier calipers, okay, first of all just let me draw a diagram, not a very accurate one but at least as the diagram that you all can understand. Okay, so if I see the vernier calipers, see there is a main scale. Okay, so there is a main scale, fine, there is a main scale like this. Okay, and there is one sliding scale. Okay, this is a jaw of the main scale. Okay, jaw of the main scale, fine. Now there is one sliding scale. Okay, so basically there is one also sliding scale. Okay, just a bit of change in the figure. Okay, it should be like this. Okay, fine. Now there is a sliding scale. Okay, so the sliding scale looks something like this. It's on the main scale, so it will be something like this. Okay, then here is the sliding scale. Okay, fine. Okay, so this is the figure, and okay, so it has certain number of divisions. Generally you will find that there are say 9 or 10 divisions. Then there are 10 divisions on the vernier scale. Okay, like this, fine. Okay, so this is the solid part, and here actually the markings of the sliding scale. Okay, so here 10 markings: 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so there are 10 markings. Okay, and the main scale reading, main scale is somewhere at this level. Okay, somewhere in this level. Okay, the main scale are there. You know the main scale is in centimeter millimeter. Okay, centimeter millimeter. So 1 centimeter, 2 centimeter, like this, 3 centimeter, 4 centimeter, like this. These are the main scale, centimeter and millimeter, and in between there will be millimeters. Okay, so like this, small, this is on millimeters. Okay, like this. Okay, something like this. So it's, I am again and again repeating that the figure is not exact or exactly accurate. The markings that I have shown is not exactly accurate. Okay, so it's just a figure that you can understand actually. Okay, so that's why I am showing this figure. Don't please go with the accuracy. Okay, and here is a screw, and on the above. Okay, here is a screw. Fine, here is a screw. Okay, so the blue colored, this part is the vernier scale, and the green color is the main scale. Okay, now what happens when you need to see, with the help of the vernier calipers, we can actually measure the, say, diameter of a sphere. Okay, or you can measure the diameter of a say your pencil. Okay, so these are small objects. Now, or say even finer objects like the diameter of a wire. You have also seen the conducting wires in your home, diameter of a conducting wire. So these are the things that we generally measure with the vernier calipers. So if you consider a spherical object and you want to measure its diameter, so what we will do, we will put the spherical object in between the jaws. These are called the jaws. Okay, these portions are called the, these two portions are called the jaws of the vernier calipers. Okay, so this is just a spherical object and you want to measure the diameter of the spherical object. Okay, so what we will do, we will put it in between the we will put it at the support of the main scale, jaw of the main scale. This is jaw of the main scale, and then we will slide the vernier scales like this over and just touch the object tightly. Okay, so attach the object tightly between the two jaws. Okay, and then we will tighten the screw here. So here is the screw. Okay, so this is the screw. We will tightly adjust the screw so that the object does not move from here. Okay, these are the jaws. Okay, these are the jaws. Fine. Okay. Now see, what we actually do, how can we actually do the measurement? Okay, so descriptive, so the construction wise description I have already given. This is the main scale. These are the jaws of the vernier calipers. This is the sliding scale. Okay, sliding scale generally have 10 divisions, and the main scale division is present on the main scale. It is marked in centimeter, and within those small divisions are the millimeters. Okay, so now we have taken an object. Say we have taken a spherical object and we want to measure the diameter of the spherical object. It's difficult to measure the diameter of the spherical object exactly with your scale. So what we do, we fix the spherical object in between the two jaws and slide these vernier calipers on the towards the left and tight the screw. Okay, so after this we have done. Then after that, what do you do? After that, we actually come to the a measurement part. Okay, now see, before telling about the measurement, there is another thing that we need to consider, that there can be some mechanical error in the vernier calipers. The vernier calipers is not always in a very good condition. It may be old, it may be bit damaged. Okay, so in those cases, what happens, some kind of error comes in the vernier calipers, and that kind of error we regard it as zero error. Okay, we regard it as zero error. So what is zero error? So please note it down. What is zero error? What is zero error? Now zero error is something that in case of a perfectly good condition vernier calipers, or which is in perfectly okay condition. Okay, what happens if we slide the vernier scale on the sliding scale, and just touch the jaw of this vernier scale with the jaw of the main scale. When there is no object in between, okay, when there is no object in between, what happens when it touches the jaw, okay? So in that case, what happens? There is a the zero of the, for a perfectly okay condition vernier calipers, what happens? The zero of the vernier scale should coincide with the zero of the main scale, okay? So remember, in general, in perfectly good condition vernier calipers, the zero of the main scale should coincide with the zero of the vernier scale. I am again repeating it, please note it down. In case of a perfectly okay condition or good condition vernier calipers, the zero of the main scale should coincide with the zero of the vernier scale. This is the first condition, okay? Now, if you see that if the zero of the main scale does not coincide with the zero of the vernier scale, then the instrument is said to have zero error, okay? So then the instrument is said to have zero error. So zero error, when we will say zero error, when we see that the zero of main scale do not coincide with zero of vernier scale, okay? Zero of vernier scale. In that case, it is said to have zero error, okay? Vernier scale. In that case, it is said to have zero error, okay? Now, this zero error can be of two types: positive zero error and negative zero error. So zero error can be of two types: positive and negative, okay? So these are two types: positive zero error, okay, and another is the negative zero error. So what are these two kinds of zero error? In case of positive zero error, if the zero of the vernier scale is on the right of the zero mark on the main scale, the zero of the, I am again repeating, zero of the vernier scale is on the right of the zero of the main scale, okay? In that case, it is said to have positive error. So just briefly write it down. Zero of the vernier scale, zero of vernier scale is on right of zero of main scale, In that case, what happens actually? It is set to positive zero error, okay? Can you see it? Oh, sorry, just shift it down a little bit, okay? So this is set to have positive zero error, okay? So I think it is now visible. Yes, okay, it's now visible, okay? So in that case, it is said to have a positive zero error, okay? And if the zero of vernier scale is on left of, this is right of the left of zero of main scale, okay, of main scale, then it is set to have negative zero error, okay? Then it is set to have negative zero error, okay? Fine. So I think the concept is clear: negative zero error and positive zero error, okay? Fine. Now let us see. How to calculate the zero error? Say for positive zero error, remember one thing: for calculating the positive zero error, let me just move down the camera a little bit down. Okay, so now I think it's visible. Okay, yes, it's not visible. So for calculating the positive zero error, say the zero of the main scale does not coincide with zero of the vernier scale, okay? Now you see that suppose the fifth division or say sixth division or seventh division, so consider the fourth division, okay? Fourth division of the vernier scale is actually coinciding with any of the main scale mark, okay? Fourth division of the vernier scale is coinciding with any of the main scale division mark, okay? So in that case, the positive zero error that comes out to be, so zero error, okay? Here the positive zero error comes out to be, so if the fourth division of the vernier scale is coinciding with any of the marking on the main scale, then 4 into the least count of the vernier scale will give you the positive zero error. Okay, and we have already discussed how to calculate the least count. Okay, so for in case of a vernier calipers, least count is again the same formula, value of one main scale division by total number of division of the vernier scale. So we have already discussed in the previous class. And in case of negative zero error, how can you calculate? This is calculated, say if I consider the fourth division of the vernier scale is coinciding with any one mark of the main scale division, then basically what we do, we first subtract the fourth division from 10. Okay, then multiply this with the least count, and since it's a negative zero error, what we do, we put a minus sign here. Okay, so this is how you can calculate the negative zero error. Okay, I think the concept is clear. I am again repeating. We are considering that the fourth division on the vernier scale is actually coinciding with the any marking of the main scale. So take 4 and multiply this with the least count, you get the positive zero error with the positive sign in front. And in case of negative zero error, if the fourth division of the vernier scale is coinciding with the any marking of the main scale division, take 4, subtract it from 10, then multiply that the difference by this count and put a negative sign beforehand. So that will give you the least count zero error of the vernier calipers. Okay, so I think now you have already understood how to correct, how to apply the concept with the zero error. Okay, then how you will get the actual reading? How can you get the actual reading? So let us come to the measurement. Okay, so what will be the actual value? Okay, so I am just erasing it off. If you have not noted down the formulas, please pause the video, move back again and note down the formula. Okay, now so what will be the correct reading? Now the correct reading will be actually observed reading minus the zero error. Okay, so correct reading will be actually, I can say, hence the correct reading, therefore correct reading is equal to, okay, is equal to observed reading. Okay, observed reading, okay, minus zero error. Okay, now the zero error should be taken with the proper sign. Zero error should be taken with proper sign. With proper sign. If a negative zero error arises, then you have to take the zero to the negative sign, and ultimately here plus will come out. Okay, and again we have not discussed how can you get the observed reading. For getting the observed reading, how can you get? So in that case, we have to take the value of the main scale reading plus okay, say, so what is the observed reading? Now from here, what is the observed reading? Okay, this observed reading comes like this. Okay, value of main scale reading, okay, plus value of the main scale reading, plus what we have to do, we have to see which division of the vernier scale is actually coinciding with any of the marking of the main scale. Then you have to multiply that particular mark or that particular division with the least count, and we will get the actual reading, observed reading. Okay, so observed reading is equal to main scale reading plus the vernier, say, main scale reading. Okay, plus what we will do, plus say the pth division or pth mark coincides with the division, any division of the main scale. Okay, so put it like this: vernier scale, vernier division, suppose say vernier division, pth division, okay, of vernier scale, pth division of vernier scale coincide with any reading of the any marking on the main scale. Okay, so take that pth value into the least count. Okay, this will give you observed reading. Okay, fine. So in this way you can actually calculate the observed value. Okay, so I think the concept of The slide calipers is clear. I think the concept of slide calipers is clear. If you have noted it down, then we'll just move on. Okay. So I think the concept of vernier calipers by now is clear. Okay. So in this way we can measure, we can take the measurement of the vernier scales with the help of the vernier scales. Okay. So with this we come to the end of this video. In the next lecture we will be discussing about how to measure any length or any dimension using the screw gauge. We will also discuss the concept of screw and the concept of the screw gauge. Okay. So till then, till the next video, please do study well and have a nice time. Goodbye. Thank you.